Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 4, 4.2, and using the binomial expansion to expand expressions of the form a plus bx to the power of n, where n is negative or a fraction. Now, in the last lesson, we looked at expressions of the form 1 plus x to the power of n, and that's the binomial expansion, where n is negative or a fraction. Well, we can expand expressions of the form a plus bx to the n by factorizing within the bracket, taking out a factor of a, and ultimately creating something that has the same form as the last lesson. So a plus bx to the n, taking a outside of the brackets, will give us a into 1 plus b over a times x, and all of that needs to be to the power of n. Splitting that into two parts, it gives us that. And then we expand 1 plus b over ax to the power of n in the normal way, just like we did in the last lesson. So in the formula, n is whatever this power is here, and x in the formula becomes this expression, b over a times by x. Okay, let's have a look at how this works out in practice. Find the binomial expansion of the square root of 4 minus x up to the term in x squared, and state the range of values of x for which it is valid. Now, I'll take you through the start and then let you finish this off. So the square root of 4 minus x is 4 minus x to the power of a half. We then factorize the 4 minus x into 4 into 1 minus a quarter x, where the whole thing has to be to the power of a half. Then we split it up into two terms, get 4 to the half times by 1 minus a quarter x to the power of a half. We can find the square root of 4, that is 2. And then this bracket, we expand using the binomial expansion in exactly the same way as we did in the last lesson. N will be a half, and x will become minus a quarter x. Okay, I'll let you have a go at completing this question. So have a go, pause the video, and come back to me when you're ready. Okay, let's have a look. So we've converted the square root of 4 minus x into this form because we can expand this in the normal way using the binomial expansion where n is a half and x is minus a quarter x. Substituting those into the formula will give us this. We only need the term up to x squared, so we can stop there. Then it's just tidying things up. That will give us that. And tidying things further ultimately gets us to 1 minus 1/8 x minus 1 over 128 times by x squared plus higher order terms. That's 1 minus a quarter x to the power of a half. We need 2 times that. So the square root of 4 minus x is 2 times by 1 minus a quarter x to the half. That means we just need to double this answer, which gives us 2 minus a quarter x minus 1 over 64x squared. So that's the first part of the question done. We're then asked which values of x for which the expansion is valid. So that's the expansion. Now what we're looking at is this term here, the minus a quarter x. It's the minus a quarter x, the modulus of that, which has to be less than 1. Modulus changes the thing to positive anyway, so we can immediately just say the modulus of a quarter x has to be less than 1. Timesing both sides by 4 gives us the modulus of x has to be less than 4, or if you prefer, you can write it as minus 4 has to be less than x, which has to be less than plus 4. Okay, example 2. Find the binomial expansion of 1 over 3 minus 2x squared, again up to the term in x squared, and once again stating the range of values of x for which the expansion is valid. So 3 minus 2x squared on the bottom will become 3 minus 2x to the power of minus 2. And then you'll need to do what we did before, where we're going to take 3 outside of the brackets. I'll let you have a go at doing the whole of it this time. So pause the video, see if you can make sense of all of this, and then come back to me when you're ready. Okay, let's have a look. So the first thing is 1 over 3 plus 2x squared is 3 plus 2x to the power of minus 2. Then we've taken 3 outside of the brackets. So that gives us 3 into 1 plus 2/3 x, all to the power of minus 2. Both of these things have to be to the power of minus 2, so we separate it into 2 terms. 3 to the power of minus 2 times by 1 plus 2/3 x to the power of minus 2. 3 to the power of minus 2 is 1 over 9. So that's where we've got so far. And then 1 plus 2/3 x to the power of minus 2, we expand that in the normal way using the binomial expansion. So n is minus 2, x is 2/3 x. Both of those we substitute into here. And that will give us that. From then on, it's just tidying things up. That would simplify to this, which ultimately simplifies to 1 minus 4/3 x plus 4/3 x squared plus higher order terms. So that's this bit here, the 1 plus 2/3 x to the minus 2. We do just need to remember that we need to times that by 1/9. So 1/9 times by this will give us 1 over 9 minus 4 over 27x plus 4 over 27x squared plus higher order terms. And then finally, we were asked to state the range of values of x for which the expansion is valid. Again, it's this term here we need to keep an eye on. So it's valid when the 2/3 x, the modulus of that, is less than 1, which means the modulus of x has to be less than 3 over 2, which you can either write like that, or you can say x has to be between minus 3 over 2 and plus 3 over 2. Okay, that gets us to the end of today's lesson. If you've got the textbook, then turn to page 38 and have a go at exercise 4B. Thank you very much for listening, and cheerio.